Good afternoon from the Johnson Space Center in Houston, Texas. I'm Dan Hewitt. 2 spacewalks in 2 weeks coming up for the crew of Expedition 36. Flight engineers Chris Cassidy from NASA and Luca Parmitano from the European Space Agency will be conducting the 2 spacewalks on July 9th and July 16th out of the Quest airlock, dubbed EVAs 22 and 23. Each spacewalk scheduled to last 6.5 hours. Here to tell us more today, I have David Korth, lead NASA Spacewalk Flight Director, and for EVA 22, Ernie Bell, Spacewalk Officer, and for EVA 23, Karina Eversley, Lead Spacewalk Officer for EVA 23. We'll hear from each of them first, and then we'll open it up for questions. David?
All right, well, good afternoon. As mentioned, we're doing a set of 2 spacewalks, the first of which is July 9th and July 16th. Tuesday, we separated them apart by a week. Both spacewalks, Chris Cassidy and Luca Parmitano, will go outside. For Chris, he has 4 spacewalks under his belt. This will be his 5th and 6th. And for Luca, this will be his 1st and 2nd. And especially for Luca, he'll be the first Italian astronaut to do a spacewalk. So I know they're both excited and ready to go. In fact, I think they were ready to go a couple of days ago. So they just got to hold on and wait for 1 more week until they get out the door for the first one. For both spacewalks, the ground support will be by astronaut Shane Kimbrough. And on board, Karen Nyberg for the first spacewalk will be doing the robotic operations. And Karen will also help out with pre- and post-EVA operations, getting in the suits and getting out of the suits before and after the EVA. And she'll be assisted by Russian cosmonaut Fyodor Yurchikhin on both EVAs for that. Why spacewalks now? The program has collected a number of tasks over the last couple of years, and we like to wait to do EVAs because EVAs cost a lot of crew time, and in the era of science and utilization, we try to minimize the perturbation to the overall operations of the U.S. laboratory and all the other laboratories on ISS. And so the program has strategically placed a couple EVAs this summer to, as we call, burn down the list of tasks that we have that require EVA. And we'll go through a list of what those tasks are for both EVAs today. Okay. All right, so let's talk about EVA 22. As I mentioned, we have a number of different tasks, and sort of a theme for both of these EVAs is that these are just a mixture of different unrelated tasks for the most part that we're trying to burn down. The first thing that we'll do is when the crew gets out the door on the first EVA, we'll kind of split them up, and we'll have Chris Cassidy doing the Space to Ground Transmitter Receiver Controller R&R. This, we call it the SGTRC, is one of 2 boxes that allow us 2 different independent strings of KU band, so we can do video, data, downlinks, and uplinks. This particular box failed in December of 2012. We've done some testing and verified, yes, indeed, this box is failed, and it does need to be replaced. The second task, again, out the door, in parallel with this, Luke is going to head over to the starboard side of the station on the starboard truss, and he's going to retrieve 2 experiments that are part of the MISSI 8 set. He's going to take both of those, bring them back in, and the plan is to return both of those experiments back on SpaceX 3 later this year. Once those 2 different tasks are completed, the crew is going to join back up together to install, or actually remove, these 2 radiator grapple bars and install one on the port side and one on the starboard side. These 2 bars, we call them the radiator grapple bars, were brought up on SpaceX 2. We've stowed them on the payload ORU attachment on the MBS, and we'd like to get them off of there and put them in more strategic locations so that they can fulfill their purpose, which they're intended to aid in remove and replace of failed thermal radiators. And so we're going to put one, as I mentioned, on the starboard side. That'll be the first task. and then following that, we'll put the other one on the port side of the truss. During this, Luca will be on the arm, and he'll be translating both the starboard and port side with the RGBs, and Chris will be at the work sites to help bolt them down. In between, going from the starboard to the port, we found a convenient opportunity. Actually, all these folks here, the EVA experts, found a convenient opportunity to remove a failed camera assembly, the mobile-based system camera light pan tilt assembly. This one failed back in May of 2012, just before HTV3. It was, at the time, one of our prime viewing cameras for monitoring visiting vehicles as they come to station. We found, of course, alternate camera views, but we don't have any spares to replace any failed units. So the idea is to bring this one back in, fly it down, refurb it, and bring it back up as a valid spare at some point in the future. So Luca is going to do that as he translates on the arm between the starboard and the port radiator grapple bar task locations. In the meantime, Chris Cassidy is going to go over and route the multipurpose laboratory module. It's a Russian module that's coming up the end of this year. He's going to complete the routing of that cable from node 1 to the interface between the PMA-1 and the Zarya module, so that the Russians on a future EVA can finish connecting that. And so that's one of a couple of things we're doing to aid in preparation for the visit of MLM later this year. Once those guys are complete with that and they've completed the port RGB install, again, Chris breaks off and he does a task. It's one of two-part tasks that he'll do for what we call the Z1. On the Z1 truss, it's a Y bypass jumper. Part 1 will be on this EVA. Part 2 will be on EVA 23. We found through various failures we've had in the past that if we lose a couple of critical external power modules or power sources, that we can lose a lot of critical loads and critical components in the station, such as one of our control moment gyros, one of the strings of the KU band system. And so some work was done earlier this year to inside the node 1 to do some cable reconfigs, and we do these two Y-pass jumper installs, and that will allow us to quickly regain these critical loads in the event of one of these external module power module failures. So the program has found this a very useful thing, rather than having to commit to an EVA after you have the failure to go restore these capabilities. And finally on the day, the two crew will join back together for the PMA-2 cover install. We have an MLI cover that we're going to go out to the PMA-2, and you can see on this graphic, it's on the very front right bottom of the graphic. They're going to install an MLI cover, and that just protects the front interface of the PMA-2 from micrometeoroid damage. And so that in a nutshell wraps up our first EVA. And as you can kind of see from this graphic here, the crew is going to be mainly centered in along the center line of the vehicle. Luca will, of course, go out to the starboard side for the Missy 8. And one thing to note, we've asked Luca that while he's out at the Missy 8 work site to take a few photos of AMS while he's out there. AMS has requested to get some better photography of their radiators and get a sense of what condition they're in. So we're going to oblige them on this EVA, and then we'll also make an attempt to take photos again at the end of EVA 23. Okay, you can go to the next graphic. And this is another view of some of the other tasks that I mentioned. Again, the Z1 jumper and the SGTRC, or the space-to-ground transmitter receiver, both located on the Z1 truss. All right, let's talk a little bit about EVA 23. That's Karina's EVA, and she'll go over more details about what we're doing, how we're going to do things during EVA 23. EVA 23, again, we start off the day. Chris is going to go out and complete part 2 of the Z1 Y bypass jumper install task. Again, both of these things together allow us to reconfigure the station just through an internal jumper in the event that we lose these external power sources. In parallel with that, Luca is going to wrap up another part of the multipurpose laboratory module, get ahead, that's routing Ethernet cable, again in preparation for MLM later this year, and the Russians will complete the connections once MLM shows up. Chris is going to also take care of another piece that enables us to replace a failed radiator, and that's this thing called the V-guides. They're going to be installed. There's 4 V-guides. We're going to install these on the port RGB and kind of position them close to where we're having to kind of guess which side that you might have the failure on, of course, but we're going to put them on the port side RGB and install them there. This does a couple of things for us. It gets them outside to free up some internal stowage volume. These were brought up a while ago, and they've been occupying internal stowage space for a while. So this helps get some free space inside the vehicle. And also, again, it gets these things outside so that in the event that we have to do a radiator remove and replace, these guides will be used to help guide in the new radiator beam into place, so they work in concert with these RGBs that we're installing. Luca, on the other side, is going to route some cables to allow us to power and get data to this payload data grapple fixture that was installed on the FGB on the Zarya module a while ago. These things, again, these EVAs are a collection of different tasks that just weren't able to be accomplished on previous EVAs, and so we've got some time to do it, so we're going to take care of these. Also, there was some grounding wire that had been seen previously that looks like it's popped up on one of the electrical connector areas on the FGB PDGF, so we're going to try to remove that and pull it out of the way. Thus, once we're complete with this, it'll enable us to utilize the FGB PDGF. The last big task that both of these crew members will do together is relocating a wireless video system external transceiver assembly. We call it the WETA. We're going to take it from the P1 location and put it onto node 2. This is in preparation for eventual plan to relocate some of the modules to free up some docking ports for future visiting vehicles, crewed visiting vehicles in the future. So this is part of a get-ahead task for something way in the future. And finally, the last thing we're going to do is remove some MLI covering from an MBSU main bus switching unit that's back out on the starboard truss near the MISSI 8 worksite. Again, this is our opportunity to take some more photos of AMS. And removing this MLI and tying it out of the way provides us an opportunity to remotely, using the SPDM, take this MBSU and eventually bring it back inside for IVA repair, so that we don't have to keep flying spares up. We can fix something that we have on orbit and refurbish it and reuse it again in the future. And so those comprise the main tasks we have for the second EVA. At this point, if you want to look at some of the graphics, again, showing some of the worksite locations. Most of these, again, are in and around the center line of the station. The Z1 jumpers, part 2, of course, on the Z1. We're going to be in and around the Node 1, Node 3, PMA1 junction areas when we're routing these MLM power and Ethernet cables going out to the interface between PMA1 and FGB. If you want to go to the next slide. And again, MBSU MLI out again on the starboard side, the wet install, bringing it from P1 back to the Node 2 area. And so this gives you kind of a sense. We're moving around the station, but we're staying inboard of both of the solar array rotary joints on both EVAs, so we're not going outboard of those. And that pretty much does it for the summary of what we're doing on both of these EVAs. So at this point, I'll pass it over to Ernie Bell, who's going to talk to you in more detail about how we're going to do things on EVA 22.
All right. Well, good afternoon. Just want to say we have an excellent EVA team put together here for EVA 22. I want to point out a couple folks that are helping us lead up this effort. On the task side of things, we have Alex Kanelakos, supported with Grant Slusser and Scott Ray. And then for the EVA systems side, we have the lead of John Malarski, and he's supported by Sandy Fletcher. Additionally, the increment team has been helping us out a lot, get everything ready for these guys to go outside. And just wanted to mention Reagan Cheney and Brian Made are doing an excellent job getting all that together. We had the opportunity to recently talk with the crew, and they are definitely looking forward to this EVA, and they are ready to go. We're going to have a couple more opportunities to do so again, just to make sure everything's cleared up and ready for them for next Tuesday. As David mentioned, Chris Cassidy is going to be EV1 on his time outside, and Luca Parmitano will be EV2. We have quite a bit of robotic operations going on EVA 22, and for this, Karen Nyberg will be supporting the crew by controlling the remote arm, the robotic arm. We're actually going to have a ground crew member who will be reading the procedures. That's Shane Kimbrough. He'll be doing so from Mission Control. So this time, we have a video of the activities for this EVA, and I'd like to go ahead and show that. So we'll start out EVA 22. Chris is going to be wearing the red stripes. He's going to be egressing first, and he's going to do so with the spare space-to-ground transmitter receiver controller. Luca Parmitano, then, he's going to be wearing the plane suit, will egress second, and he'll take with him a cover for one of the MISSI experiments, the Ormate. So the first task for Chris, he'll translate aft on the airlock and up to the top of Z1, and he's going to get in position to replace the failed SGTRC. So he'll first stow the bag with the replacement SGTRC on top of the Z1 truss. He'll set up a temporary hardware stanchion, which he'll then attach the spare SGTRC to. So he retrieves it and places it on top. He'll then move over to the failed unit and get in position to release it via 3 bolts. Here you actually see a picture of Chris in the neutral buoyancy lab practicing this actual procedure. Once he's removed the failed one, he'll grab the spare and install it into the same location. And once complete, he'll stow the failed inside the bag, place the hardware stanchion inside the bag, and close it up. Once complete with the task, he'll return to the airlock where he'll stow this entire bag inside. Now, while Chris has been working on the SGTRC, Luca has translated up the CETA spur to the outboard side starboard truss to the Express Logistics Carrier number 2, where the MISSI experiment is located. This actually includes 2 items, the optical reflector materials experiment, or the Ormate, and the payload experiment container, the PEC. So he'll get up onto position there in the forward zenith side of ELC2. And first thing he'll do is take some pictures of the material experiment. He'll also look over at inboard and take some photos of the AMS, as David had mentioned earlier. Put a cover on the Ormate, remove it, and place it on his mini workstation. He'll then close the PEC, where the experiment was actually inside of it now. And here's a photo of the experiment on orbit, so you can see the hardware. He'll demate 2 cables from the PEC and connect them to the base. At this point, he'll release the PEC payload and stow it on his body restraint tether and translate back to the airlock. At the airlock, he'll actually stow both the Ormate and the PEC inside, and we can expect both the crew to be back at the airlock together at about this time. They'll then begin their next task, which is a starboard radiator grapple bar install. For this, Chris will translate up to the starboard CETA cart with a large ORU bag that he's going to use for some flight support equipment brackets that he'll later remove from the RGBs. So he'll place this bag on the CETA cart. He's going to actually take out a large or a handling device, go up onto the mobile base system, and place this handling fixture or scoop onto the mass camera. This is for use later by Luca. He'll then go back to the CETA cart. Meanwhile, Luca has been retrieving a foot restraint He'll actually gather this from the forward side of the external stowage platform number 2. He'll put on his BRT and then translate out port, just slightly port of where Chris has been working, where he'll begin steps to ingress the arm. So once he's on location, he'll put the foot restraint at the end of the arm, and then he'll ingress the foot restraint. At which point Karen is going to fly him over and get him in position where he'll be able to take control of the first of 2 RGBs. Meanwhile, Chris is moving around, breaking torque on the 4 bolts that hold this first RGB to the second one. On the forward side there, you see him, he'll release 2 bolts, translate around onto the second RGB, and then move back inboard so that Luca can move into position to take control of this first RGB. Once Luca takes control of it, Chris will release the second 2 bolts. Karen will fly Luca out, and Luca will then reposition the RGB into a better attitude for installation over on the starboard thermal radiator rotary joint, or the targe. And this arm maneuver here is going to be about a 15-minute maneuver. So he'll fly up over the station and get into position. Now during this maneuver, Chris is actually going to remove the 2 flight support equipment brackets that were used to hold the 2 RGBs together. He'll stow them back in the large ORU bag, which is over there on the seated cart. There's the first one, and now working on the second one. Once he has those both removed, he's going to translate outboard on the starboard side of the truss, and he'll meet up with Luca for the installation of this first RGB. So once in position, the 2 of them will work together to align the RGB on the stow bolts, on the stow beams. See there, and then they will iteratively work back and forth to secure the 2 bolts to mount that to the targe. Here's a photo from the neutral buoyancy lab of this task taking place. Once complete, Luke will be flown back towards the second RGB, which is still located at the POA. During the maneuver, Chris is actually going to translate back towards the airlock. And once he gets down to the airlock, he'll translate to the zenith forward high pressure gas tank. And here he'll retrieve the MLM power cable. This was previously staged there by Sonny Williams on EVA 18. The task here is to route the cable along the starboard side of node 1 and onto the PMA 1, or pressurized mating adapter number 1, on the aft side of node 1. Once Chris gets this task complete, he's going to translate back towards the port seated cart where he was earlier to help with the release of the second RGB from the POA. But first, Luca, on the flight over to the second RGB, is going to be brought in to remove a failed mass camera on the MBS. He'll drive a single bolt. That'll release that camera, and then Karen will fly him away and the rest of the way over to the second RGB. And once he's in position, he'll actually hand the camera off to Chris. Chris will then retreat aft near the seated cart. Luca will take control of the RGB. Chris will help work clearances, and they'll fly him out away from the POA. Again, Luca will rotate the RGB for the installation, this time over on the port targe. This flight here is actually about a 27-minute maneuver, so it's a pretty long arm maneuver. So there is, again, some time for Chris to go and work some other tasks. During this flight, then, Chris will return to the airlock, drop off the failed camera, grab 2 bags, one being a PMA-2 cover bag and the other a crew lock bag. We'll translate out to the forward end of the station where PMA-2 is and drop off the PMA-2 cover bag. He's not going to install the cover yet, but he will stage the bag. At this point, he's going to begin translating back to the port targe. Along the way, he'll drop off his crew lock bag. It's for use later with the Z1 Y bypass cable task. We'll translate the rest of the way out to the port targe. And timing working out, Luca will be arriving right around this time. So they'll again work together to stow this RGB in the same fashion that they did the first one. They'll work to align it onto the stow beams and then take turns iteratively driving the 2 bolts to secure it to the targe beam. At this point, Luca will be flown back to the same location where he ingressed the arm. It's about a 13-minute maneuver. Be a slightly different orientation, but essentially the same location. He'll egress the foot restraint and then remove the foot restraint from the arm and take it back down to ESP2 where he retrieved it from earlier in the EVA. At this point, Chris has translated back, picked up his crew lock bag, and is heading around to the aft side of Node 1 to a bag there called auxiliary bag number 1, where he's going to retrieve the 2 cables for the Z1 Y bypass task. So we'll retrieve those 2 cables and translate up over the top of Node 1 to the port side of Z1 truss segment. Once he gets onto work site, first thing he's going to need to do is to reorient a foot restraint out of the way, and then he'll stage his crew lock bag. There's just a few tools and caps and such for the cable task. And then he will work the cable installs. He'll actually do a complete install of the Nader cable or the 4 Bravo cable. He'll do a partial install of the 3 Bravo cable or the Zenith one. That one's actually going to be completed on EVA 23. At this point, he returns to the airlock and stows the crew lock bag. At this point is another sync point for the crew where they'll both translate forward on station out to the PMA-2 location, where they'll work in conjunction to install the PMA-2 cover around the forward end of the PMA-2. There's basically a number of Velcro straps that they're going to cinch down onto the handrails around the circumference. One of the crew members then will pick up the PMA-2 cover bag, translate back to the airlock. This bag will be stowed inside the airlock and brought inside at ingress. The other crew member is actually going to translate back to the port CETA cart where the large RU bag, which contains those FSE brackets, is going to pick up that bag and then take it down to the airlock. Now this bag actually won't be brought inside on this EVA. The airlock's getting pretty full, so instead the crew is going to stow it on the starboard end there of the airlock. See right there where the handrails are flashing, and now place the bag there. Once this is complete, Luca will ingress first, Chris will ingress second, close the hatch, and this will complete the EVA-2 tasks. So that's the big overview there of the EVA-22. Actually have a couple items, we'll go ahead and show here for this EVA. A lot of the items that they're working with are fairly large, but of the smaller ones, it's a couple of mock-ups of from the pool. The Z1Y bypass jumper install, as David had mentioned, is a fairly important task to provide redundancy for the station in the future, but what it comes down to is it's just simply 2 cables of about this length, one end with a Y, to provide redundancy from one location or another for power, and then the outlet. So that's really about all it amounts to, is installing 2 of those, which seems very simple. Hopefully it will be. And then the other item that's actually small enough to bring in here and show you guys. is the Ormade experiment. And for this experiment, there is actually a cover that the crew, this is a mock-up again from the NBL, but the experiment would be here, and then Luca would actually install a cover onto it when he's out at the work site, use that to protect the material samples and experiment that's inside of it, and then bring that back inside. Oh boy, it's, I'm going to have to double check on that. It's the size here, it's probably something like that, maybe, yeah, somewhere in that range. It might be a little bit heavier than that, though, I think, than a laptop, yeah. So that's the two pieces of hardware I was able to bring in. The RGBs are pretty good size, so didn't exactly want to have this up here at the desk. Yeah, they're a couple 100 pounds or so. At this point, we can go ahead and turn it over to Karina for EVA 23.
All right, thanks, Ernie. I'd like to start by thanking my excellent EVA team for EVA 23, which is my task lead, Sandy Moore, task 2, Scott Ray, and my EMU systems lead, David Simon. And I will second Ernie's thanks to the lead EVA team for increment 36, Grant Slusser as the lead, with Brian Mader and Reagan Cheney helping him out because they're doing all the preparations for these EVAs on board, coordinating with the crew. In addition, I'd like to thank astronauts Doug Wheelock and David St. Jacques for their terrific help in developing the timeline for EVA 23. This EVA was envisioned at the point when Chris and Luca were nearly finished with their training. And so Doug and David did all the hard work in the neutral buoyancy lab to help us develop the timeline. And Shane Kimbrough will also be the ground IV reading out the procedures for EVA 23 as well. And with that, if we can bring up the video for EVA 23. So on US EVA 23, EV2, Luca Parmitano will egress the airlock first. He'll be wearing the pure white suit. He'll bring out a bag containing some cables that he'll be installing during the EVA, and then attach his own and Chris's safety tethers outside the airlock. EV1, Chris Cassidy, wearing the red striped suit, will egress and retrieve 2 more large bags from the airlock. One contains the 4 radiator V-guides, and the other is an empty bag in which he'll stow the main bus switching unit multi-layer insulation towards the end of the EVA. Chris will translate up over the airlock and across the top of the Z1 truss, and then down to the port side of Z1, where he will work on the second of the 2 Y bypass jumpers. And this one will have been temporarily stowed on the previous EVA, as Ernie mentioned. He'll be working with the upper cables in this view. And what he's actually going to do is swap 2 connectors. In this graphic here, the 2 connectors indicated by the double-headed arrow will swap, and then the 2 connectors in the blue circles will swap. And in the end, then, the green cable will have been replaced by the Y bypass jumper in red, which provides powers from 2 different sources. Meanwhile, Luca will take his bag of cables from the airlock and translate under the Unity node. He'll go to its upper aft end cone, where he'll temporarily stow that bag, and you can see the 2 handrails. He'll stow it between blinking here. Then he'll retrieve the multi-purpose laboratory module Ethernet cable from the bag and translate to the forward end cone of Unity, where he'll connect the cable to a spare Ethernet connector that is located in the corner between US Lab and the Unity and Tranquility nodes. Luca will lay the cable out as he translates back aft towards the Russian segment, and he'll be restraining the cable onto handrails and other structure using EVA wire ties. This MLM Ethernet cable actually includes 4 additional extra connectors on its forward end that can be used for future Ethernet expansion capability. When Luca reaches the forward end of the Zarya Russian module, he will tie off the end of the cable on a handrail, where a Russian crew will complete the connection to a cable they will route later this year during a Russian EVA. After Chris finishes with the Z1 Y bypass jumper, he'll return to the airlock to retrieve the large bag containing the 4 V-guides. And he'll head out over the lab and out to the port 1 or P1 truss. You can see the translation path he'll be taking highlighted by the handrails blinking there. And then he'll go down to the nadir side, or the bottom side of the truss, where he and Luca installed one of the radiator grapple bars on the previous EVA. Once he's there, he'll bolt the 4 V-guides onto stowage brackets attached to the grapple bar. And like the grapple bars, the V-guides, each one has 2 bolts that zip into the nut first, and then the EVA power tool or pistol grip tool is used to provide the final torque. While Chris is working with the radiator V-guides, Luca will continue with several tasks to finish the outfitting of the power and data grapple fixture, or PDGF, on the Zarya module. And first he's going to be checking for a misconfigured grounding wire inside one of the connector doors, which you see blinking here. Mike Fossum actually cleared one of the connector doors on STS-135. You can see that one in the upper right photo with the little white wire that's poking out of the door there. But the yellow arrows point to a couple little white dots that we can see behind the other door. And we think that although Mike inspected it and it appeared clear, it's possible that the door just pushed that wire out of the way. So in this video, you can see what Luca will have to do is peel back the multi-layer insulation around the PDGF, and he'll use the large hook from his waist tether in order to open the connector doors so he doesn't have to stick his fingers inside there. And he'll do an inspection to see if he sees anything. But then because the door may have actually pushed that wire out of the way, we will locate it. It's a grounding wire for the multi-layer insulation, and just gently pull it out, make sure there's no loose wire inside that connector cavity. And he'll twist it around to keep it out of the way, and then restrain it in place by putting the multi-layer insulation back, and it's just attached with Velcro. And then he'll do one final look inside the connector to make sure everything looks clear. Once he's complete with that task, Luca will release a short segment of the data cable for the PDGF and route it forward onto the pressurized mating adapter. This one's actually attached to the PDGF already. And he'll attach that to a handrail on the PMA. Then he'll return to his cable bag and retrieve the 1553 data cable, which he will attach to that short pigtail. And this actually uses Russian-style connectors on those 2 cables there. And then he'll route the cable across the pressurized mating adapter over to a connector panel on the Tranquility node. And the 1553 cable is actually a pair of cables that have been taped together just to make them easier to route by EVA, and it provides 2 data channels for the PDGF. So after Luca has connected the 2 cables, the ground will do a quick check to verify good communication on both channels. While that's being done, Luca will clean up his work site and retrieve the cable bag. He'll stow that in the airlock and then translate out to meet Chris at the P1 truss for the wireless video system external transceiver assembly, or WETA, antenna relocation task. So this is on the zenith side, just above where Chris was working on the V-guides. And the crew will work together to demate 3 connectors from P1 and then release a single large bolt that holds the antenna stanchion to the space station. They'll position the WETA and its stanchion on Chris's body restraint tether and retrieve their tool bags, and then they will carefully together translate down towards the Node 2 Harmony aft end cone. You can see the translation path they'll be taking. And we have them do this together just because the antenna is very large, and so it helps Chris to make sure that it doesn't get bumped into anything along the way. Once at the Harmony's upper aft end, they'll return the antenna to a vertical position and drive the bolt to secure it in the Harmony module. You'll see the Neutral Buoyancy Lab footage of them working with this antenna, and it's about 7 feet long. So it's also one of the 3 antennas that provide our helmet camera video during spacewalks. When this antenna is installed, the crew will then remate the 3 connectors to a connector panel on Harmony, and which provides power to the antenna as well as the video signal back to us. And then they'll retrieve their tool bags and return back to the airlock. Chris will stow the bag that carried the V-guides and retrieve a large empty bag for the main bus switching unit multi-layer insulation. And then he will be heading out to the Express Logistics Carrier number 2 on the zenith side of the starboard 3 truss. You can see his translation path here. And you can also see the alpha magnetic spectrometer AMS right next to that work site. This is the current location of the failed main bus switching unit that was changed out on US EVAs 18 and 19 in August of 2012. And Chris will be removing a large insulation blanket from the MBSU. He'll stow it inside of his bag. and then he'll use some EVA wire ties to restrain the flaps around the perimeter of the MBSU so they don't get in the way of robotic interfaces, and it can be brought inside robotically, as David mentioned earlier. During this time, Luca will either be finishing up the PDGF tasks he was working on earlier, or he may assist Chris in completing the blanket removal tasks and taking additional photos of the AMS. And that's the end of the planned timeline. We do have some get-aheads. A key one is the replacement of the camera on the forward corner of the Japanese experiment module exposed facility. Chris Cassidy actually installed this camera on his previous shuttle mission, so he's very familiar with that work site. And then the crew will return to the airlock. They'll stow their hardware, including the radiator grapple bar FSC bag that was left outside from EVA 22 and ingress, and that will be the end of EVA 23.
Okay, well, with that, we'll go ahead and open things up for questions. We'll start with reporters here in the room, then move to the phone bridge. As always, if you could state your name and affiliation and who the question is for, it would be much appreciated. We'll start right up here up front.
Gina Sinceri, ABC News. You mentioned you wanted to take some shots of AMS. What's the motivation for that? Curiosity, or is there a scientific purpose to it?
Yeah, my understanding, it's not a scientific reason. They've seen some discoloration on the radiators. They're not sure if that was something in ground processing or some phenomenon that's happened on orbit. So they've asked if we could just get some photos, since we'll be near the work site and we'll have good angles when we're out on the starboard side near the Missy 8 and the MBSU MLI tasks.
Jim Oberg with NBC. A couple of questions. Is it correct to suggest the theme of a lot of this work is to modify the station hardware and layout to increase the depth of single fail tolerance for the future? In other words, you are doing a lot of rewiring in anticipation of future failures to make it easier to react to them. Is that a correct interpretation?
Yeah, I'd say it's twofold. One, it is making it more robust, which is what you're getting at. The other thing is some of the tasks that we mentioned are intended to prepare us for future relocations and realignment of things to make station more usable by visiting vehicles.
Thank you. And the second thing, I was trying to flash a sign here about some of the big items you're handling, the 7-foot antenna. There's other boxes. Those are crewman-sized boxes. What kind of mass are we talking about with these large objects? Can we find out? I mean, I don't need it off the top of my head. It's not for the trivia contest, but
yeah, we can find out.
Okay.
I can tell you the Weta and stanchion combined is about 168 pounds, so it's not overly large in comparison to some things that we've handled. The wireless video system. The antenna and the stanchion. It's really just because the antenna stands up off of the space station on this long stanchion, so that's about 7 feet long.
And there's no planned jettison or release of anything?
Correct.
Okay. Well, we'll keep watching for it. Thank you very much. It's spectacular graphics, and it was very easy to follow. The preparation for that is a big kudos to whoever worked that. It's very good. Thank you.
Thanks, Mark Carreau for Aviation Week. I had a couple of questions. The Russian cable work for the MLM, will that follow the arrival of the MLM, or will it occur during some of the spacewalks on the Russian side that are planned, I think, for August at this point, or even later this year?
Yeah, they're going to be, the Russians are going to pick up where we leave off later on this year.
So they'll have that all in place before MLM arrives?
That's my understanding.
Okay. And then I think this question is for you too, David. I wonder if you could go over the Z1 Y jumper cable. The reason for doing that is, again, it sounds like some of the things Jim spoke about in terms of being ready to deal with an external electrical issue if you need to, but be able to deal with it inside and robotically. I got lost in there, to be honest. Okay.
Yeah. See, I don't know if it's easy to pull up a graphic. Karina had one in hers, but while she's doing that, the purpose is there's some external power boxes. We call them DDCs, DC-DC converter units that distribute power to loads both externally and internally. There are a couple of them that if we were to lose them for some reason, and we've had issues in the past where things may have gone offline or whatever, in order to recover some of these critical loads that they supply power to, such as a control moment gyro, the S-band, the SGTRC that we're actually replacing, and the S-GAN, which is the big KU-band dish antenna that it attaches to, those will go offline if we lose that DDCU. So what we're doing is we're rerouting kind of between the DDCU and some of the downstream other power distribution boxes. We're inserting this Y cable that enables us, once you do some internal wiring, which has already been done, to reroute the power distribution to power these loads I mentioned, just with switching a cable inside. And so it makes it much more robust. And here's what Karina's showing. There's two sets of cables that are required, one the blue, one the red, that provide us the ability to reroute power to provide alternate source of power to these critical loads should one of these external boxes fail.
Follow-up. This is a design feature. Is that a design feature?
Aaron Berger with the Houston Chronicle. I would echo Jim's comments about the quality of the graphics. And I would just ask a general question. I'm curious how much EVA training the astronauts on the station get versus those that are going on planned shuttle missions who have designated tasks when they were building the station. Do the ISS crew members get more or less EVA training?
I'd have to say, in general, they get less. It's more generic training that they get for station crew members. Now, Chris has actually been up on shuttle flights, so he's had EVA experience during shuttle flights. For EVA 22, Chris and Luca actually worked together, I believe it was on 2 different NBL runs for this timeline that they're going to see on EVA 22. So they've actually trained the specific tasks on this EVA. They additionally had another run individually with other crew members, but with the same task. So they've actually seen this EVA 3 times already on the ground. Generally, we would have 5 to 7 runs for a shuttle crew. But you incorporate the generic training that they have, and they are more than ready for these EVAs. There are a lot of generic type of tasks actually associated with these type of EVAs, particularly for EVA 22.
Okay. Let's go to the phone bridge real quick. I think we have Mike Wall from space.com. Mike, can you hear me?
Oh, yeah. Hi, guys. Thanks for doing this. This goes out to pretty much anybody who would want to comment on it. Do you guys actually see any implications from the crash of the Proton rocket on Monday, or is that something that's not going to factor in at all to your plans?
Yeah, that's David Korth. No, there's no implications to our EVAs, and frankly, I defer anything else on that topic to our colleagues in Roscosmos.
Thank you.
All right, we'll come to the room for follow-ups. Jim?
Yeah, there's a whole bunch of interesting follow-ups here. You discussed in training. Although there's more generic training and less task training, aren't these tasks now being designed to actually rely on existing generic training profiles? So that it would be wrong to say that the generic training is not all that helpful for specific training, because you are designing the current tasks to rely on generic training procedures. Is that something that you're doing philosophically?
I think I'll give a shot at answering, and I'll let Karina follow up here too. Generically, yes, there is a protocol or a set of training runs that they'll go through, which will prepare them for a number of EVAs that they may need to do on station that they may not anticipate having to do until they get there. So the generic training will cover a lot of things like generic electrical connectors, bolts, other types of work that they may have to do, the use of the tools. These EVAs happen to encompass tasks that pretty much the extent of training needed for them is, for the most part, generic type of training. Now, if there was more extensive or more elaborate type of tasks that would be required, it's possible we may specifically train a specific crew to, once they get on orbit, to perform that task. I think that hopefully that answered your question, but Karina might have additional words with her experience.
I don't want to put words in your mouth, but that seems like the way you're going. And so that it would just because there are only 3 task-specific runs for these training compared to 5 to 7 for shuttle crews does not mean the crew is only half as well prepared.
That's correct. They're just as prepared.
There you go. Thank you.
I'm sorry.
Karina, go ahead.
Yeah, their training, you might use the term skills-based training is what they get generically. And one of the advantages then of training a specific timeline is the choreography of the timeline and how the tasks work out together. And we can do a lot of that with a crew. Like I mentioned, Doug and David helped us develop EVA 23. And so from that development, then we provide information to the crew on board with, just little details about how things line up together in a specific timeline. But the tasks and what they're doing is really covered by their skills-based training.
Thank you.
All right, Mark.
Thanks. Mark Carreau for Aviation Week again. I had a couple of questions. One, the activities near the AMS, do you have to power that observatory off during that, or does it remain on?
Yeah, they'll remain on.
And this is another explainer question. The V guides, I understand, are part of the, I guess, preparation for possible change out of radiators. How do they work? I'm not sure if.
You guys want to try? Or?
Yeah,
Sure.
kind of may work together. The V-guides on EVA 23 are being stowed on a radiator grapple bar, which is just a temporary stowage location. That's not the location they would be used in if we had to do a radiator R&R. I think would be a clarifying point. For the radiator R&R itself, they'd actually be located 2 on either side of whichever particular radiator needed to be replaced and used as a guidance for the removing and changing out the radiator.
So there's actually some bars on the grapple bar itself that kind of go down the V guides, and they help align it as the RMS would bring the new radiator into place.
All right, any more follow-ups? Okay. Then with that, we'll go ahead and wrap up. NASA TV coverage for both spacewalks will begin at 6 a.m. Central Time. First one coming up on July 9th, the second on July 16th. Both spacewalks scheduled